Hello. Today I'm going to explain the homework program, section 6.1, which is about finding the volume of the solid in 3 dimensions. There are 15 programs to go. First one is just a review from chapter 5. So number 1, find the d by dw for the function y in terms of w. Well, you can use fundamental theorem of calculus for this one. So let's differentiate both sides of the expression by w. And by fundamental theorem, this is going to become just a square root of 15 plus 16 w squared. Okay, number 2. A solid lies between planes perpendicular to x-axis at x is equal to 0 and x is equal to 9. So let's say we have x-axis and here's y-axis, and here x is 0 through 9. The cross-section perpendicular to the axis on the interval of 0 through 9 are squares with diagonals that run from parabola. Y is equal to negative 2 square root of x. To the parabola, y is 2 square root of x. So here you have two graphs, which is y is equal to 2 square root of x, and y is equal to negative 2 square root of x. So the cross-section perpendicular to the x-axis is a square with a diagonal that run from the parabola, whatever to whatever. So this is a perpendicular line to the x-axis. And this is going to be, from this point to this point, going to be the diagonals of the square. So this is diagonal, 対角線. So in this case, the graph looks like this way. So in the 3-dimensional situation, so we have a square where the diagonal is given like this. So diagonal is on this plane. So in the 3 dimension, it's going to be like this. And below the xy plane, you're going to have the other half of the square. So that's a square. So you have a bunch of squares like here, and up to here. Okay. So you have a square piled up from 0 through 9. To find the area of the square with the diagonal is known is simple. Area of the square is, of course, length times width. That's one way. But another way to find the area of the square is a diagonal times diagonal divided by 2, which is a way to find the area of the rhombus. ひし形のね、面積求めるときの公式が対角線かける対角線割2ですけど、正方形でも使えます。So let's find the volume now. So volume will be the integral of the surface, cross-sectional area where x is 0 through 9. And the cross-sectional area is, the diagonal length will be the y coordinate of this point minus y coordinate of this point. That's going to be the length here. So length here going to be 2 square root of x minus 2 square root of x. That's the length of the diagonal. Square the diagonal and divide it by 2 to find the area of the square. Okay, so that's going to be 1/2 times 4 square root of x squared. So it's going to be 8x, 0 through 9. So that's going to be 4x squared after integrating, and it's going to be 324. So the answer will be 324. Okay, next one is a bit easier because you can see the figure where the cross section has some kind of triangle. Okay, so number 3. Find the volume of the following solids. The base of the solid is a region between the curve y is equal to 12 square root of sine x and the x-axis. And the cross sections perpendicular to x-axis are, first case is first case is the equilateral triangle. So just look at this cross section. Okay, so let's say this is an equilateral triangle. So just pick this point is any point on the x coordinate, x-axis. So that's going to be x0. And this point will have same x-axis, x coordinate as this point, but the y coordinate satisfies this equation. So it is 12 square root of sine x. So the length here, length of the side of the equilateral triangle is 12 square root of sine x. y 座標の差ですね。y 座標の差。So that's going to be one side of the length. Well, how do we find the area of the equilateral triangle? So let's say one side is S. Then by drawing the perpendicular line here, this is going to be like 30 degree, 60 degree, 90 degree right triangle. So ratio is 1 to square root of 3. Okay, so the area going to be 1/2 times base times the height. That's going to be 4 square root of 3 s squared. Okay, so that's going to be the area of the cross section. So volume will be integral. X is between 0 through pi of the cross sectional area. And the cross sectional area in this case is just area of the equilateral triangle, which is square root of 3/4 times one side length square. So that's gonna be 36 square root of 3 came out. And it's gonna become just the integral of sine x. Integral of sine x is negative cosine x. And you plug in pi and 0, so it's gonna be 72 square root of 3. So because we need to find it in exact form, we should write down 72 square root of 3. Now, part B is, we don't have a figure, but the case squares with bases running from x-axis to the curve. So now, this part doesn't change. This part doesn't change. But instead of the forming an equilateral triangle, now you wanna create a square with this side as a base. In the previous question, it was this side become a diagonal, but this one becomes a base. So to find the area of this one is very simple. The volume will be integral of 0 through pi of the base, cross-sectional area. Okay, and the cross-sectional area is just all squares whose one side length is this. So area of the square is, you just square, side length square, that's the area of the square. So it's gonna be 144 integral of sine x, and that's gonna be 288 after you do the integration. Those answers are gonna be 288. Now next problem, number 4. A solid lies between the plane perpendicular to the y-axis and y is equal to 0 and 2. Now this one is actually cross-section perpendicular to y-axis, so we have to consider in this way. Okay. So you have some kind of parabola in this direction. So this expression is x is equal to square root of 3y squared. And the cross-section perpendicular to y-axis. So perpendicular to y-axis. So we are really looking at the three-dimensional space, and you are looking at the plane on y somewhere. And it's going to be a circular disk with diameter is this. So this is going to be the diameter. This is going to be the diameter. This is going to be the diameter, and this is going to be the diameter. So what we really have here is, so in three-dimensional case, this is going to be the circle here, and this is going to be a circle here, this is going to be circle here, this is going to be circle here, and so on. Okay. All we need to know is length here is a diameter. So we want to know the length here. Now pick any point between, along the y-axis between 0 through 2. So this point is 0, y somewhere between 0 through 2. Then this point have a same y coordinate as this point. Okay. And the x coordinate will be, because it satisfies this, it can be written as square root of 3y squared. The length here is the distance between, with a horizontal difference, horizontal length. So we can find the difference of the right point minus the left point to find the length. 右の y 座標から、右の x 座標から、左の x 座標を引いて、that's gonna be the length of this segment. And that's gonna be a diameter of the circle. Okay. How do you find the area of the circle if you know the diameter? Well, if you know the diameter, then you divide it by 2 to get the radius, and you're gonna square the radius and multiply it by pi. So that's gonna be the cross-sectional area in this problem. So to find the volume, we just integrate 0 through 2 in y direction. Now area will be pi times radius. So this is the diameter divided by 2 to get the radius, and you're gonna square it. So it's gonna be 4, 3 pi out of y to the 4th. Okay, so that's gonna be the, we just need to find this integral, which is y/5 divided by 5, 0 through 2. So it's gonna be 32, 8, 24 pi over 5. So answer in exact form, so it's gonna be 24 pi over 5. Okay, number 6. This is something, it's just like, well, there's no curve involved. So you can use the junior high school math formula to find the volume of the pyramid. But if we really want to do the integral to find this, then first of all, we have to think about on which direction we wanna take the cross sections. So, well, let's integrate along x-axis. Okay, let's integrate along x-axis. So the length here is 0 through 75. So we are going to integrate between x of 0 through 75. Then you are going to find the cross sections. So just pick random point along the x-axis, and we are interested in the shape of the cross section. Now we know this is 21, it's here, and here's 72, like this. So if you look at the perpendicular plane with respect to x-axis that goes through this point, then cross-sectional area looks like this. Okay, so that's gonna be the area. That's gonna be the shape of the cross-section at the randomly chosen point x on the x-axis. To find the area of this one, we are interested in finding area of this one. We need to know the length here and the length here. To do so, you will need to use the ratios of the similar triangles. Now looking at the bottom, looking at the XY plane, the larger triangle have a 72 here and a 75 here. And we know this is X, and we want to know this length here. So what is this? What is this? So using the ratio, this is gonna be 75 minus X. So the ratio will be using similarity, 75 minus X over Y is same thing as 75 over 72. That can be reduced to 24 and 25. That's still a big number, which is not so nice. So what is Y? So Y will be this. So that's gonna be the length, the base length of this red rectangle. If you do the same thing for X and Z relationship, so again, we have, we are interested in find the length here, but we are doing almost same thing here. So instead of 72, you are going to use 21 here. So instead of 24 here, you want to get 7 here. So Z will be 7, 75 minus X over 25. Okay, so this Y represent the length here, and this Z represent the height here. So the cross-sectional area are going to be 1/2 times base length times the height, which will be 1/2 times 25, 24, 75 minus X times 25, 7, 75 minus X dx. Let's put the big numbers out. So 225 square, 724, those constant out. And so it is just an integral of a quadratic function like this. So when you integrate this one, you want to get the cube divided by -3, and you want to plug in 0 through 75. Forget about this part for a moment. Plugging 75 doesn't give you anything, it's just 0. And plugging 0, you want to get 75 cube. So after this, you have to simplify the expression. Let's just write down cube as 75 times 75 times 75. And let's write down 25 square as 25 times 25. Okay, now reduce the fractions. So this is gonna be 75 gone, and this is gonna become 3, and this is gonna be 12. So we just need to do this computation. So let's break down this one to 4 times 3. So 4 times 75 is 300 times 3 times 3 times 7. So 900 times 21. So it's gonna be 189.00. Okay, now we come to the revolution problem. So now we have X and Y. The line here is 4X plus 5Y is equal to 20. Find the volume of the solids generated by revolving the shaded region about the X-axis. So this direction, okay? So we are interested in the cross sections. Looking at this line, any point, pick any point on the X-axis, which is perpendicular to, so this red line gonna be perpendicular to the axis of revolution. Now, volume is integral of the cross-section area, where X is from 0 through, in this case, X-axis, X-intercept is 5. So it's going to be 0 through 5. And because this is a revolution, you want to get the cross section is always a circle whose radius will be this length. So this length is just a y. So y is equal to 20 minus 4x over 5. That's a radius here. Okay. You just find the length of y coordinate here, y coordinate here, and you subtract the y coordinates from one another to get the length here. So it is pi times radius square. Okay. Since this is a linear expression inside, let's put 5 square out. So it's going to be 20 minus 4x squared dx. So after integrated, well, you can put 4 out, actually, 4 square out. You can put 4 square out, which makes the expression easier. Then you take an integral. So it's going to be, again, it's going to be like a negative 3, 5 minus x cubed, 0 through 5. So it's going to be like last program, it's going to be 5 cubed. Okay, so simplify this, and you're going to get 80 pi over 3. Okay, now revolving about the y-axis. So revolving in this direction. So from the picture, we can use y's from 0 through 1. Pick any segment here randomly. Pick any y here. Pick any y here, 0 y here. Then this coordinate will be xy will be 2 tangent pi y over 3 comma y. So the length here will be basically this. Okay, length here gonna be the difference between the x coordinate, which is just this. Okay, so revolving give you the circles, bunch of circles. So the volume will be 0 through 1 in y direction, where the where the cross-sectional area will be pi times radius square, and the radius will be tangent square. Put 4 pi out. So it's going to be integral of tangent function. Do you remember how to integrate the tangent square? Well, use the following identity. 1 plus tangent square is secant square. So you can rewrite the tangent square as secant square. So it is secant square of this angle minus 1. The antiderivative of secant square is a tangent. So it's going to be what? Tangent pi y over 3. But be careful about the chain rule. It's going to be 3 over pi in front. And integral of 1 will be y. Now plug in 1, you're going to get the tangent of pi over 3, which is square root of 3. Tangent of 60 だね。Tangent 60 degree is square root of 3 minus 1. And if you plug in 0, you're going to get tangent 0, which is 0. So that's going to be it. So it's going to be 12 square root of 3 minus 4 pi. So answer in exact form, 12 minus 3 minus 4 pi. Okay, number 8. Find the volume of the solid generated by revolving region bounded by the given line and the curve about the x-axis. So now this is x-axis again. So you have actually semicircle. Y is equal to square root of 25 minus x squared, where the center is origin and the radius is actually 5. So when you revolve this one, rotate this one with respect to x-axis, you're gonna get the sphere. So if you know that the answer to this problem is just finding a volume of the sphere with a radius 5, you can use 4 pi r cube over 3 to find the volume immediately. But if you want to do the integration, pick random point along the axis of revolution, and you're going to find a cross-sectional area. So you are interested in finding this length because that's going to be the radius of the cross-sectional part circle. So the volume will be the integral of cross-sectional area between -5 through 5. And the cross-sectional area will be pi times the radius square, where the radius is just like a length here, which is basically y coordinate. So it's going to be radius square. So that's going to be pi times 25 minus x squared dx. Now integrate this one, where it's going to be simple. So pi put out, integral will be 25x minus x cubed over 3, -5 to 5. Of course, you could use a even function property to simplify this a bit. But let's just plug in. So this is after you plug in 5. And when you plug in -5, you're going to get the negative version. So everything is a mode for 125. So put 125 out. So it is this. So inside the parentheses become 4 over 3. So the answer is 500 pi over 3. Okay, and another revolution problem. So you have y is equal to e to the x minus 4. And we are interested to find the area between, well, volume of this part when this is rotated with respect to x-axis. So radius is this, okay, radius is this. So the volume will be 4 through 7 integral of pi times radius square, where radius is this y value here. So radius is this dy. So it's y through 7, 4 through 7 of e 2x minus 8 dy. No, not dy, dx. Okay. Integrating this one, you're gonna get still the exponential function, but don't forget about divided by 2. And you plug in 4 through 7. When you plug in 7, it's gonna be e to the 6. When you plug in 4, it's gonna be e to the 0, which is not 0, but it's going to be 1. So don't be careful about this. So it's going to be e to the 6 minus 1 times pi over 2. Okay, next one is basically the same. Find the volume of the solid generated by generating this function from -1 through +1 in y direction. Okay, so revolution with respect to y-axis of this part. So because revolution with respect to y-axis This recording is going on. Let's see. Let's try to do it once again. We'll have to restart the Pearson. COVID's gone. Okay. That's not what I want. Let me pause the record now. Okay, I'm gonna resume the recording. I don't know where it was stopped, but let's do. Okay, so for problem number 10, the graph looks like this. We are interested in cross-sectional area, so pick random point on the y-axis, which is 0, y. Then you are interested to find the lengths here. So this point is x, y, but x can be expressed in terms of y like this. So the cross-sectional area will be just a circle whose radius is gonna be just this, okay? So the volume will be integrating y direction for 0 through -1 through 1 of pi times radius square. So that's gonna be 5 pi of y to the power 4th, -1 through 1. Of course, using even function property, you can just multiply this one by 2. And so it's going to be 2 pi after you do the definite integral. Okay, next one is now you have to use the washer method. So graph is given like this, and you have another graph like this. So we are interested in the region of -pi/3 through pi/3 in x direction. And this is y is equal to 4. So when you look at the cross-sectional area, pick any point on the x-axis, which is axis of revolution. And we are going to rotate this part. You're going to find a cross-sectional area, which can be provided by the revolution. So when this green part is revoluted with respect to x-axis, you're going to get the ring like this. Ring. Okay. To find the area of the ring, you need to find the radius of the bigger circle, outer circle, and you need to know the radius of the inner circle. And that's corresponding to length here and the length here. Okay. So the smaller radius will be the y coordinate of this function, the smaller function, which is 4 times square root of cosine x. While the larger radius is basically 4 everywhere. Okay, everywhere is 4 in this interval. So now volume will be, you want to integrate from pi third, -pi3 to pi3 in x direction. Area of the larger circle, which is pi times bigger radius square, minus the whole part, which is going to be area of the smaller circle. You can put the pi out. The bigger radius square is 16, and the smaller radius square is 16 times cosine x. This is an even function, so you can put the 2 out and make it to 0 through pi/3. of 16 minus 16 cosine x. Let's put 16 out as well and integrate 1 minus cosine. So it's going to be x minus sine. So it's going to be 32 pi over 3 minus sine of pi over 3 is square root of 3 over 2. And when you plug in 0 here, you're going to get zeros. So that's going to be the answer. Okay. Number 12. Find the volume of the solid generated by revolving the region bounded by the given curve and line about the x-axis. So again, it's x-axis question. So you have a line y is equal to 5x. And now you have y is equal to 5 and x is equal to 0. So we are interested to make a revolution of this part. Okay. So this point is x is 1, and this point is when x is 0. So we are going to make a revolution for x between 0 through 1. Now the cross-sectional area gonna be, again, it's gonna be a ring. Okay, the outer radius gonna be 5 everywhere, while the inner radius gonna be 5x. So it will be pi times bigger radius square minus pi times smaller radius square. So you can put 25 pi out. It's going to be 1 minus x squared. And when you integrate this one, it's going to be x minus x cubed over 3. That's going to be 2/3. So the answer is 50 pi over 3. By the way, for this one, you really do not need integrals, because when you revolve this one, you want to get the cylinder with radius is 5 and the height is 1. And you have a cone like this, whose radius is, base radius is 5 and height is 1. So we can find the area of the cylinder by just using a formula, pi r squared times height, to find the area of the cylinder like this. And to find the volume of the cone, you can just divide by pi times base radius square times height divided by 3, which is 25 pi divided by 3. So that's going to give you the answer immediately. Okay, number 13. So find the volume of the solid generated by revolving region bounded by the graph of parabola and the line about the x-axis. So you have a parabola here and you have a line like this way. So y is equal to 2x plus 12, and the parabola is y equal to 2x squared plus 1. And you're gonna make a revolution of this region. Okay, so we want to know where they meet. So we're gonna find when, for what value of x they meet. So because that's gonna be the upper and the lower part of the integral. So it's gonna be 2x squared minus 2x minus 11 is equal to 0. Really? That doesn't sound so nice. Huh. Well, unfortunately, we don't have a very good number. So it's gonna be 4 to square root of 4 plus 88. So it's gonna be 1 plus minus square root of 23. over 2. So unfortunately, this is a very ugly number here, but it's gonna be like 1 minus square root of 23 over 2 here, and here gonna be 1 plus square root of 23 here. Okay. For convenience, just let's say this is alpha, and let's say this is beta. So to find the volume, we just take an integral of the cross-sectional area between alpha and beta. So cross-sectional area is, again, it's going to be a ring. So the outer radius is this, and the lower radius is this. So it's going to be pi times, the upper radius is just the y coordinate on the line. And the lower part is pi times radius is the y coordinate on the parabola. So it's going to be 2x squared plus 1 square. Now, this is a very ugly computation. And because the question is asking for round to the nearest hundredths, you might be able to just use a calculator to find the area. I mean, the volume of this one. But if you do it by hand, that's going to be a bit nasty. Yeah, it's going to be terrible. So let's expand this one. So it's going to be 4x squared plus 48x plus 144 minus 4x to the fourth minus 4x squared minus 1. So it's going to be minus 4x to the fourth. This is gone, plus 48x plus 143. That's not so nice. That's not so nice. Let's divide this one by, let's factor this one actually. Well, you can integrate this one without difficulty, but the issue is you're gonna plug in these ugly numbers later, which is something I wanna avoid if I had to do it by hand. So maybe factoring might be better. So let's factor this one. So square minus square, so it's gonna be addition and subtraction. Well, unfortunately, we cannot factor this one. So I guess that doesn't give me anything nice. So I guess I had to integrate this one by hand. So it's going to be negative 4/5 of x a fifth plus 24x squared plus 143x. And you plug in alpha and beta. So it's going to be negative 4/5 beta to the fifth minus alpha to the fifth plus 24 beta square minus alpha square plus 143 beta minus alpha. You might have to do some using property of the symmetric expressions, but I think it's going to be still very ugly, especially we have power of 5. Well, what we are interested to use is beta minus alpha is a simple number, because although beta is complicated, alpha is complicated, the difference is just the square root of 23. So that's something we are interested to use, especially this part is done. And also this part can be split into beta minus alpha and beta plus alpha. So, and beta plus alpha is just equal to 1. So that's quite nice. So this part is very easy to take care of. The problem is the power of 5 here. So this can be also break down into something like this, but we will need more work to do. That's something out of topic of this section, so I'm not going to explain it. So please feel free to use a calculator to find the volume after you set up the equation here, okay? Well, next one is you have a triangle. Oh. So you have a triangle. One is 2, 1 here. Another one is 2, 4 here. And another one is 6, 4. So you have a triangle here. And you're going to rotate this one with respect to y-axis. So this is actually a simple question. So you are interested in the cross sections, which is perpendicular to y-axis. So you are going to rotate this line with respect to y-axis. So you're going to get the ring. You will need a washer method. And to do the washer method, you need to know radius of the bigger one and the radius of the smaller one. Okay. Radius of the bigger one is basically the x coordinate of on this line. So we want to express this line first. So because this is just a line, so slope is 3/4. So this is going to be 3/4 and go through the point 2, 1. So that's going to be the line. And this one is very simple. That's going to be just x is equal to 2. Yeah. We write this expression for x in terms of y. So let's multiply this one by 4 first. Like this. And you solve for x. Solve for x. So it's going to be 4y is equal to 3x minus 2. So x is 4y plus 2 over 3. Okay, that's x coordinate here. And that's going to be the length here. Okay, so once you set up this one, it's going to be the volume integrating from 1 through 4 in y direction. So pi times the bigger radius square. What? I hit this one. So pi times bigger radius square. So bigger radius is this. Minus this part, which you really do not need to do the integral, but because it's just a cylinder, but it's going to be radius is 2 everywhere. Basically, radius is 2 everywhere. So you can integrate this. So let's skip the integration this part. Just focus on this part. So it's going to be 9 pi. Let's put 9 pi out. So it's going to be 4y plus 2 square dy. And this part is basically a cylinder whose height is 3, 4 minus 1, 3, and the radius is 2. So it's going to be 12 pi here. So integrating this one will give us some 4y plus 2 cubed divided by 3 and divided by 4. And you plug in 1 through 4. So 9 times 3 times 4 outside. When you plug in 4 here, it's going to be 18 cubed. And when you plug in 1 here, it's going to be 6 cubed. So after this is just a simplification. Let's put 6 cubed out. So 6 times 6 times 6 out. So it's going to be 3 cubed minus 1 here. So it's going to be 6, 6, 6, and 26, 9, 3, 4. So simplify, and simplify. So it's going to be 104 pi over 2. So it's going to be 52 pi. So that's going to be 52 pi minus 12 pi. So the answer is going to be 40 pi. Sorry for messy computation, because I'm frustrated with my computer. Last one, number 15. Find the volume of the solid generated by revolving the following region about the given axis. Okay, so find the region in the first quadrant bounded above by the y equal x squared. So this is going to be upper bound, below by x-axis, so that's going to be lower bound, and right by x is equal to 2. So x is equal to 2, and left by, oh no, it's not left by. So this is bounded by here. So this is going to be the region, and you want to make a revolution with about the line x is equal to -3. So this is the axis of revolution. Okay, now we're gonna make a revolution of this part. Okay, so we again will need a washer method. So we are interested to integrate in direction of y instead of x, because the cross-sectional area perpendicular to the axis of revolution is this direction. Okay, so we are interested in this part, but actually because it's going to be a ring again, the red part with respect to this one going to be a ring. So we need to know bigger radius, which is this, and minus the smaller radius square. Okay, we need to know this. Well, look at the bigger radius is always 5. The red is always 5 in this interval. Okay, it's always 5. So it's just like a cylinder with base radius is 5 and height is what? Here is height is 4 here. So height is 4. So this part is, we don't need the integration. Now we look at the orange part. So the orange part will be something like this. Okay. So length here will be the x coordinate on this curve minus x coordinate on the blue line. So just focus on this part. The color doesn't change. So this is y is equal to x squared. And we want to know the horizontal distance from here to here. Okay. So we really want to know the x coordinate here. Okay. With given value of y. So when y is given, the x coordinate must be square root of y. This coordinate is -3y, same y value, but the x coordinate is -3. So the distance here gonna be 右引く左, so it's gonna be square root of y minus -3. That's the horizontal length. So let's find the volume of the orange part. So integration from 0 through 4 of the pi times radius square. Okay, so that's gonna be the orange part. Before integrating, because this is a nonlinear term, so I had to expand it. So we're gonna integrate this. So let's put pi out. It's gonna be 1/2 y squared plus y to the 3/2, 3/2, it's gonna be 4 plus 9y, 0 through 4. So that's gonna be plugging 4, it's gonna be 8, 2, 8, 32, plus 36, and 0, 0, 0, 0. So it's gonna be 76 pi. So that's the orange part. What was the bigger part? Okay, outer one gonna give you 100 pi by pi times radius square h. So the answer gonna be 100 pi minus 76 pi. So the answer will be 24 pi. Okay, so that's complete explanation for 6.1. I'm sorry for kind of rush, explaining in rush because I'm still struggling with my eyes. So I don't want to spend much time in front of computer. And I hate this computer's behavior today anyway. Well, good luck on your final exams. Have a nice day.